Alright, to simplify rational expressions, and that's what we're doing, simplifying rational expressions, we need to factor these expressions. 5x is already factored, so that one's pretty simple. But then we need to factor the next polynomial, which means what two numbers add up to 3, or multiply to 3 and add up to 4. Which that one's a pretty simple one in terms of 1 and 3. Then the bottom, the x minus 6 is already factored. But we need to factor this difference of squares. Difference of squares is x plus 3 and x minus 3. Now from here, anything that's exactly the same on top and bottom of the fraction can be canceled. So this x plus 3 and this x plus 3 can be canceled out. And so we're left with 5x times x plus 1. And on the denominator we have x minus 6 and x minus 3. Now anytime we have a fraction as an answer, we need to identify in the denominator as long as that denominator can never equal 0. So what we have is called undefined terms, numbers or values. And in this case, x cannot be 6 and x cannot be 3. Because when I put either one of those in, I get 0, and you can never have a 0 in the denominator. So we're going to define conditions where the denominator is 0 after we simplify. So let's go through the process of simplifying. The numerator is already factored. 4y, y minus 3, and y plus 4. The denominator, though, needs to be factored, so I have a y. So I'm looking for two numbers to multiply to negative 6 and add up to negative 1. And that happens to be negative 3 and a positive 2. Now I have it factored, so I'm canceling out everything that's exactly the same. So I'm going to use my blue line. This and this are exactly the same. This y is exactly the same with that y. What I'm left with then is 4 times y plus 4 on the numerator. And the denominator, I'm left with just y plus 2. And our undefined part is whatever makes this 0. So y cannot be negative 2. So now let's look at this next example. Everything but this part right here has been factored. So I have 2z times z plus 5. And then this needs to be factored. So it's going to become what two numbers multiply to give us negative 8 and add up to a 2, which happens to be z plus 4, z minus 2. There's our numerator. Denominator is already factored. We got z minus 1. We have z plus 5. And we have z minus 2. So I'm canceling out anything exactly the same. So z minus 2's cancel. The z plus 5's cancel. And so we're left with 2z times z plus 4 all over z minus 1. And so our undefined terms is what makes this 0. And so z cannot be 1. And there's our answer. Sometimes after simplifying, you have things that look the same, but we'll have to use this negative 1 to be able to do the problem. So let's go through factoring. In this problem, we are factoring when using the greatest common factor. W is the greatest common factor between these. So if I factor it out, I get this. W plus y is already factored, so there's my numerator. My denominator has 3y minus 4w. And then I have 5w plus y. Now if you look at these two look alike right here. I'm just going to circle them. These two look alike except that the signs are opposite. I have a negative 3 and a positive 3. I have a negative 4 and a positive 4. So what I can do is I can factor one of them with a negative 1. I'm going to always do the top. So if I take out a negative 1 from this, I get negative 4w plus 3y, and my w plus y, there's my top. My denominator, I'm going to change it in the right order. That's still a negative 4w plus 3y, and I just changed the order, this one right here, so it looks the same. And if I look at this, these two now are identical, so I can cross them out. And I did that only because I factored out a negative 1 to make them look alike. So what I'm left with is So I'm left with this part of the polynomial but by canceling out, and that means I now have a -1 w plus y on the numerator and 5w plus y in the denominator. And there's my answer.